Hey, pre-calculus. This is the third part to section 4.7, which is all about the inverse trig functions and their graphs and everything. So in this section right there, we're going to look at a little bit more complex values of trying to apply these ratios both to special right triangles, 30, 60, 90, and 45, 45, 90s, plus angles that necessarily aren't in those really nice special right triangles. And I'll show you some techniques to help you out with that. So one thing to kind of keep in mind as we go through are those principal value intervals. All right, that restricted domain that kind of helps us out. All right, for the inverse sine, or again the arc sine, you're going to have anything in negative pi over 2 to within pi over 2. So again, you're thinking that's between quadrants 4 and quadrants 1. All right. For the inverse cosine, you're going to return values between 0 and pi. So it's going to be with quadrants 1 and quadrant 2. And then for the inverse tangent, you're going to return everything similar to the inverse sine between negative pi over 2 and positive pi over 2, or between negative 90 and positive 90 degrees. That also is quadrant 4 and quadrant number 1. So those are the only values that you'll get out, but that doesn't necessarily mean that those are the only answers that you can have. And remember from the other video, we'll show you kind of how that works. All right. So with something that might look a little bit more complex, always start within the middle of the parentheses, always inside of the innermost parentheses, and then work your way out. So inside the innermost parentheses, we have this guy right here, the inverse sine of root 3 over 2. And that's from one of the other videos that we watched that might make a little bit more sense. So you're thinking, what angle specifically is going to give you a ratio of root 3 over 2 when you're dealing with the sine? So if you use the hand trick, you want sine, lower half of your hand, 3 fingers up, 1, 2, 3, fold that guy back. You can use your triangle method to try to figure that out. But hopefully you're a little bit more comfortable in saying, well, that right there has got to be an angle of pi over 3 or 60 degrees. Now that's the innermost part. I'm not done with the problem yet. I still have this cosine I got to deal with. So what I want to do is calculate the cosine of pi over 3. So I'm thinking, what is the specific answer? What is the ratio of pi over 3 for the cosine? So again, you can go back to the triangle method, or you can go back to the hand trick. And I know pi over 3 is going to be that ring finger. I can fold that back, and the cosine's the upper half of the hand. So there's one finger up. So that's got to equal 1 over 2. So I got 1/2 as my final answer there. So essentially what I'm doing is I'm trying to figure out an angle to figure out a ratio. And I got to kind of work backwards with that one. All right, number 2, the sine of the arc sine of 1/2. So work in the middle first, the arc sine or the inverse sine of 1/2. So the arc sine or the inverse sine of 1/2. And I'm thinking, okay, if I use my hand trick and it sines the lower half of my hand, I want one finger up. So I fold the next finger back. Oh, okay, that's the pointer finger. That's got to be a pi over 6. So pi over 6 is what that blue part is, but I'm not done yet. I want to figure out what is the sine of pi over 6. So the sine of pi over 6, I go through and I can go back to the hand trick, or I can go back to the triangle method. Maybe I'll go to the triangle method right there, and I can draw in that triangle. Pi over 6 is the same thing as 30 degrees. So that's my reference angle right there. And I can say 30 degrees, I'd say that's a 1, that's a root 3, and that's a 2. And I know the sine's got to be the opposite over the hypotenuse. So I'm thinking opposite's 1, hypotenuse is 2, so that's got to be a 1/2. So my answer is 1/2. Oh, and it kind of goes back to right there, 1/2, because the sine and the arc sine kind of cancel each other out. They're inverse operations, so they'll undo each other there. All right, how about this one? The inverse sine of the tangent of negative pi over 4. So we work in the middle to begin with, the tangent of negative pi over 4. So I'm thinking, what specifically is that ratio? Now I'm not coming up with an angle because I have an angle. I have that angle as pi over 4, negative pi over 4. So I have to try to figure out what exactly is the tangent of negative pi over 4. All right, well I could use a hand trick. Pi over 4 is the 45-degree mark right there. And I know the tangent is going to be the sine ratio over the cosine ratio. So with that hand trick, I've got root 2 over 2 over root 2 over 2, and that simplifies down to just 1. All right, but I've got this negative pi over 4, so I know because it's negative, that means it's going to be quadrant number 4, not quadrant number 1. And going back to all students take calculus, in quadrant number 4, Quadrant number 4, tangent's got to be negative. So my answer is not 1, it's actually going to be a negative 1. All right, so all that green part is negative 1. I still have to keep going. I got to deal with the inverse sine of that. So I have to figure out what is the inverse sine of negative 1. What angle will give me a sine ratio of negative 1? That's kind of the way you think about that. All right, so if I want that negative 1 right there, if I use that hand trick right there, I would say sine's the lower half of the hand, and I want the full 1 right there. So that's not just one finger, because that would be 1/2. So that's actually what, root 4 over 2. I want 4 fingers. 4 fingers. So I'm going to count 1, 2, 3, 4. Fold the next one back, and that's up at the tippy top. That's 90 degrees. That's pi over 2. That's pi over 2. But pi over 2, that's going to be a positive answer, and I want a negative answer. So I actually want it to be negative pi over 2, or negative 90 degrees. All right. If you wanted to see that with the hand trick or with the triangle trick to kind of help you out, if that maybe makes a little bit more sense. All right. I'm going to put my theta maybe down there in the corner. All right. And I know sine's got to be the opposite over the hypotenuse. So the opposite side's got to be a negative 1. All right, and the hypotenuse has got to be a positive 1. And I'm thinking if I use the Pythagorean theorem, there's nothing left over right here. So that's got to be a 0. So what specific angle will give me, a distance right here of nothing, meaning it's squished up. So really this corner right here matches up with that corner right there. They're at the same spot. So that tells me it's a 90-degree angle. And because it was a negative 1, it's actually going to be downward if I think about the unit circle right there. So negative 90 degrees. All right, so that's kind of the idea with the triangle method. All right, and finally, number 4, I've got the inverse sine of the cosine of negative pi over 6. So I'm trying to figure out the cosine of negative pi over 6. So if I think about where negative pi over 6 is on the unit circle, negative pi, that's a really bad unit circle. I could do a better job than that. I apologize. My circle skills that's still a pretty bad unit circle. Let's start all over. Let's start all over. How about that? Okay, that's much better. So a negative pi over 6. Well, here's a positive pi over 6. So a negative pi over 6 would be right there. So I'm in quadrant number 4. So I know cosine's going to be positive in quadrant number 4. Oh, okay. So my answer is going to be a positive ratio, whatever that is. So pi over 6, if I use the hand trick, that's the pointer finger right there. I can fold that back. Cosine's the upper half of the hand. I've got 3 fingers up, so that's actually going to be a root 3 over 2. And I'm going to keep that positive because I was in quadrant number 4, not anywhere else. So I've got root 3 over 2. Now I've got to apply the inverse sine of that. I'm trying to figure out the inverse sine of root 3 over 2. So what angle gives you a sine ratio of root 3 over 2? So I think about the hand trick, and I want sine lower half of the hand. And I want 3 fingers up on the lower half of the hand. That's 1, 2, 3. And I can fold that guy back right there. So that's going to be a pi over 3. So pi over 3 is what I got. Or if you want to go in degree mode, you can think of that as 60 degrees. 60 degrees. All right. What if you deal with angles that aren't necessarily part of your 30, 60, 90 or 45, 45, 90 right triangles? In that case, then, you're definitely going to want to make sure you've got your calculator, but be careful of your mode. All right, be careful of your mode. So, for example, the first one, the inverse tangent of 1.5. The inverse tangent of 1.5, and they ask for the answer in radians. Inverse tangent of 1.5 in radians. So I'm going to bring up my calculator right there. There we go. And I want to make sure my mode is in radians to begin with, and it sure is. So I can quit out of that. All right, so I'm in radian mode, and I want the inverse tangent of 1.5. So I'm going to go second tangent to be inverse tangent, and I could go 1.5. All right, close that parenthesis if I need to. And I get my value is about 0.9827 and so on and so on. Whatever value you're supposed to round it to, so maybe 0.983 looks good. All right, so that looks good right there for that one, 0.983. If I go back to this problem right here, all right, I can say, oh, that's a 0.983. All right, next one. I want to try to figure out the value in terms of degrees. So I want to switch my mode up to be degrees. The arc cosine of negative 0.15. Really, I'm thinking the inverse cosine of negative 0.15. That's the same exact problem. So I go back over to my calculator, switch the mode up. So I go to the mode, and I'm going to go down here to degrees, and I can enter on that one, and I can quit out of that. And I want the inverse cosine or the arc cosine of negative 0.15. All right, just pretty much type it into the calculator right there. So I got a 98.62 or so, 98.6 degrees. So that's what I'd end up with, a 98.6 degrees, because I'd asked for it in degree mode, not in radian mode. All right, so that's something you can use to kind of use your calculator with as you go through. And a couple other problems that we have here that might be a little bit more challenging for you right here. So if I said the sine of the arc tangent of root 3 plus the arc cotangent of root 3 is what I'm trying to figure out. So again, work more in the parentheses first. So maybe try this first little problem right here, the arc tangent of root 3. You're trying to figure out what angle specifically is going to give you a tangent value of root 3. All right. So you can think of the tangent really is going to be the sine over the cosine. All right. As you go through and you calculate that, you should realize that's going to be a pi over 3 right there. All right, you're going to do the same thing with the arc cotangent of root 3. So what angle is going to give you a cotangent value of root 3? All right, and that one on the other hand is just going to be a pi over 6. The value that you need to do is you got to add these guys together. So we have to add together first because that's still all in the parentheses. So you're thinking pi over 3 plus pi over 6. Well, maybe get a common denominator right there of 6. So you could say that's really going to be, the blue one's going to be a 2 pi over 6, plus the green one's still a 1 pi over 6. Well, 2 pi plus 1 pi is 3 pi, so that's going to be a 3 pi over 6, and that simplifies down to just be pi over 2. So pi over 2 is all this blue and green added together. So I want to try to figure out what is the sine of pi over 2. Oh, okay, I can use my hand trick right there. Pi over 2 is at the tippy top. I can fold that pinky back. Sine's the lower half of the hand. I've got 4 fingers up right there. So that's actually going to be a 1. The sine of pi over 2 is 1, so the sine of the arc tangent of root 3 plus the arc cotangent of root 3 is a 1. So a little bit trickier, You have to realize how to figure out the blue part, the arc tangent of root 3, and the green part, the arc cotangent of root 3. All right, and that goes back to making sure we understand the hand trick, or we understand the 30, 60, 90 triangles, or the 45, 45, 90 right triangles. So if you need to kind of refresh your memory about that, or dust off that old unit circle to help you out with those values, that's where we're at. All right, we'll try a couple more of these. The sine of the inverse tangent of 1 plus the cosine of the inverse cosine of a half. Okay, so the sine of the inverse tangent of 1. What angle is going to give you a tangent value of 1? What angle is going to give you a tangent value of 1? That's where we might want to start. We might say, okay, that means that tangent value is 1. Tangent really is going to be the sine over the cosine. So if you're going to divide sine and cosine, you want to get 1. You want to be having them have the same exact thing. So that means the only place they're the same exact thing is root 2 over 2 and root 2 over 2. All right, that'll give you a 1. So the root 2 over 2 and root 2 over 2, that's 45 degrees, or you can think of that as pi over 4. So pi over 4 is that first part. All right, so we got to figure out the sine of pi over 4. Plus, we also want to figure out the cosine, and you're thinking the inverse cosine of a half. So what angle is going to give you a cosine value of 1/2? That's kind of the question that you've got to ask yourself right there. Well, if you want to use the hand trick, you can. Cosine's the lower half of the, or the upper half of the hand, and you only want 1/2, so 1 finger up. So you can fold back the ring finger. Oh, that ring finger, that's going to be a pi over 3. So that's got to be a pi over 3 for that part right there. And now I've got to kind of calculate these two new problems. The sine of pi over 4. So the sine of pi over 4, I can say, oh, pi over 4 is the middle finger. Sine's lower half of the hand, so that's got to be a root 2 over 2. And then the cosine pi over 3 is going to be the ring finger. Cosine's upper half of the hand, that's 1/2. So I can add that to 1/2. Oh, look, remember this? Cosine, inverse cosine, they cancel out. That would have helped us out a little bit. But to add these two together, we want to make sure we get common denominators, and we do. Root 2 over 2 plus 1/2 is root 2 plus 1 over 2, and that's about as far as I can go. All right. All right, there's some other ones right here. I'm not going to go through the logistics on how to solve them, but I will give you the final answer. So if you want to take a moment here and pause the video and try these two out, and then you can check your answers, might be a good idea. Otherwise, you can kind of just see what they were, and we'll definitely practice a little bit more in class with these. All right, so go ahead and pause now and try these two problems. Did you pause? I don't think you did. You're lying. Pause it now, for real. Okay, great. All right, so number 3 right there. Number 3, I would say the arc sine of root 2 over 2 is going to be pi over 4, so that's going to be a tangent of pi over 4, and then minus the cotangent of the arc cosine of root 2 over 2. Arc cosine of root 2 over 2 is pi over 4, so that's the kind of the first step. The tangent of pi over 4 is 1. The cotangent of pi over 4 is 1, and I got to subtract them. When I do that, I get out a 0. So hopefully you got 0 for that first one. Number 4 right there, tangent still on the outside, not going to do that yet, but the inverse sine of root 3 over 2, that's going to end up being a pi over a 3, and then the inverse cosine of root 3 over 2, that'll end up being a pi over 6. I need to make sure I subtract them, get a common denominator right there. When I do that, I get tangent is equal to tangent of pi over 6. Just like so, and then I got to make sure I calculate the tangent of pi over 6. When I do that, I get a root 3 over 3. I can box that in, and I'm in good shape. All right, last couple problems here for you. Last couple problems here. Sometimes if you don't have those ratios that work out pretty nicely in your 30, 60, 90 or 45, 45, 90, it might be better just to draw the triangle and kind of work through the problem that way. So for example, the cosine of the inverse tangent of 8 over 5. You know tangent right there has got to be the opposite over the adjacent. So what I would do is sketch out a little right triangle, put theta down in the corner, and I can say the opposite side's got to be 8 and the adjacent side's got to be 5, and then use Pythagorean theorem to figure out what the hypotenuse is going to be. So you'd say 8 squared is 64, 5 squared is 25, you add 64 and 25, you get 89, so the hypotenuse has got to be the square root of 89. If you're looking for the cosine, cosine's got to be the adjacent over the hypotenuse. Well, you know the adjacent to theta is 5, and the hypotenuse is root 89, so the cosine's got to be 5 over root 89. And if you rationalize this, you can multiply top and bottom by root 89 over root 89, and that'll give you a 5 root 89 over 89. You simplify if you can, but in this case you can't. All right, if I look at another one here, in the tangent of the inverse sine of negative 5/6. So again, maybe draw out a right triangle. All right, put a theta down there in the corner. And sine, opposite over hypotenuse. So the opposite, I'll move that negative side up to the numerator. So the opposite's negative 5. The hypotenuse is going to be 6. So go through Pythagorean theorem, 6 squared, 36, negative 5 squared is 25, subtract them, you get 11, so that's the square root of 11 for that third side. And if you want the tangent, you know has got to be the opposite over adjacent, so the opposite over adjacent, so the tangent's got to be a negative 5 over root 11. If you rationalize this, you'll get a negative 5 root 11 over 11, kind of like so. And the last one, the cosecant of the inverse cosine of negative root 5 over 5. Again, make that negative go up top to the numerator. All right, this is another one that you might want to pause and try. All right, and then unpause and see what the answer is. So I'll let you go ahead and give it a pause, see if you can try it, and then unpause it. Go ahead and pause for real this time. Again, I don't think you paused it. I'm calling your bluff right there. Really, for real, pause. Give it a try. It's not going to hurt you. Just go ahead and pause it. Okay. All right. Hopefully you did. Hopefully you did. If you did, you get 5 bonus points. All right. So let's see here. We draw out our right triangle. You put theta right there. And you say cosine. Cosine's the adjacent over the hypotenuse. So that's a negative root 5 down here. And that's a 5 as the hypotenuse. Use the Pythagorean theorem. 5 squared is 25. Root 5 squared is 5. Subtract them and you get root 20. All right. But that simplifies down because you got a 4 in there. So that could be 2 root 5. 2 root 5 is what we got. Awesome. Okay. I want the cosecant though. If you forgot what cosecant was, it was the reciprocal of sine. So therefore we can say it's the hypotenuse over the opposite. So the hypotenuse is going to be 5, and the opposite is going to be 2 root 5. So the cosecant is going to be 5 divided by 2 root 5. Okay, all right, and I want to make sure I rationalize this. So I multiply top and bottom by root 5 over root 5, and that gives me then a 5 root 5 over, let's hear, 2 times root 5 times root 5, that's 2 times 5, that would be 10. And then I can simplify one more time because I got a 5 and a 10, so that would be a root 5 over 2. So hopefully you got a root 5 over 2 when you unpause this. And you see, that's all I got. If you got questions for me, be sure to write them down and ask me. I'll see you next time, guys. Have a good one. Bye-bye.